Okay, we will start today's class. So today we have started, we will start second law of thermodynamics today, okay? So till now we have covered zeroth law of dynamics, first law of thermodynamics, okay? Now before zeroth law we talked about systems surrounding different kind of processes. Got it? Right everyone? Now when we talk about this topic, second law of thermodynamics. So the first thing is what are covered in this topic. Okay, so let's see the concepts which is being covered in this topic. Now, when you talk about the topics, when you talk about the concepts, okay, so these are the major concepts that will be covered in this topic. So first, what is entropy? What is the meaning of spontaneity of a reaction? Okay, second is the basic statement of second law of thermodynamics. Okay, the basic statement of second law of thermodynamics and the relationship between heat and entropy. Then we have different formulas of entropy, relationship between enthalpy and entropy, then Gibbs free energy, and the feasibility of reaction, like when reaction is spontaneous or non-spontaneous. Okay, so this is a brief review of the chapter. Okay, yeah, wait everyone. Yeah, as I said, my internet is very annoying, so it will be disconnecting in between. So if I'm silent, just think that I got disconnected. I'll be reconnected within few minutes. Okay. Okay then. So when we talk about this second law of thermodynamics, right? We have to understand what's the basic statement of second law of thermodynamics. What second law of thermodynamics says. Okay. Now in first law of thermodynamics, we studied that the net sum of energy is constant, or you can say that energy is conserved, right? Energy is conserved. So I can see that the first law of thermodynamics states that total energy of a universe remain constant, right? Now my second question would be, if energy is constant, suppose energy is constant, right? Now what about the motion of a particle, right? Or any process, where the process will go. For example, if I talk about heat exchange, so we studied that heat will transfer from higher temperature to lower temperature, right? That's what we have studied. That heat will transfer from higher temperature to lower temperature. That's what you have studied, right? But is it the only condition for any process to happen? Is it only condition? Like only the heat exchange is sufficient enough for any process to be happening? Tell me. There should be something. Now just take an example. Take an example of refrigerator, right? Take example of refrigerator. So we have a freezer, right? And then we have your fridge. So we know that freezer makes fridge cool, right? So the air is circulated inside the fridge, right? Now we know that the temperature of freezer is less, and the temperature of air, which is in the freeze, not in the freezer, right, is usually warm as compared to the freezer. Okay, so if the temperature change was only requirement, then this fridge should work automatically, right? We have fridge here, and then we have a gas, right? But when we talk about a fridge, there's a very important component of fridge, that is your condenser, right? Right, everyone? What is the work of condenser? Tell me, what is the work of condenser? Tell me, everyone. Anyone know what is the work of condenser? Have anyone see? Sorry, not condenser. You can see it as compressor. Both are same actually, right? So compressor or condenser. What do you think? Just see at the back of your fridge. There'll be a small tank-like thing, okay? That is your compressor. पीछे देख लो, खोलना नहीं पड़ेगा, okay? It is visible, okay? Just turn your fridge, you can see your compressor, okay? So yeah, so even though the heat should flow from higher temperature to low temperature, still we have a compressor, right? So I can say that it is not possible always for object or for any process to move from higher temperature to low temperature spontaneously without some work done, okay, right? Or I can say that it is not possible for total amount of energy to get converted into work without some heat loss, right? Got it, everyone? So the statement was given by a few scientists of second law of thermodynamics. So second law of thermodynamics states that all processes have natural direction. Okay, all processes have natural direction, right? Which not only depends on temperature change, but also a concept called entropy. Okay, so I can say that if any process have a natural direction, right, then that direction should be spontaneous, right? Okay, it should be spontaneous. Now, the first law of thermodynamics don't tell us about the direction of a process, right? It just let us know about the heat change, internal energy, and work done. It doesn't give us any idea about where the process is going on, in which direction it is going on. Okay, now that is explained by second law of thermodynamics. Okay, and the concept of entropy. Natural direction means the direction which is spontaneous. Okay, for example, when you talk about ice, right? If you keep your ice in normal room temperature, so it will melt. So that is its natural direction. Got it? But when you keep your water, right, will it evaporate? If you keep, or will it vaporize? Forget about evaporate. Will it vaporize? Or got it? So there are some natural direction which is spontaneous. Okay, that is your natural direction. So I can say that any process will be carried out in its natural direction till the time equilibrium is achieved. Okay, so any spontaneous process will be carried out until the equilibrium is achieved. Okay, got it, everyone? Just think about your melting of ice. It will melt, ice will melt until the temperature is equal to room temperature, right? Because for that the equilibrium condition is your room temperature. Got it? right? Now, apart from temperature, there's another thing which is changing, which is the phase. Yes or no? Which is the phase. Okay, now we'll discuss more about what is the change in phase. Okay, how it is related with the second law of thermodynamics. So there was two scientists who gave this statement according to second law of thermodynamics. The first was Clausius. So he said that no process is possible. No process is possible for the sole reason of transfer of heat. Okay, because there must be something, there must be some work done. Okay, so no process is possible whose sole result is transfer of heat from body of lower temperature to body of higher temperature. This was the statement given by Clausius. Okay, so we can understand that. We can understand that. See, the example that I gave you in refrigerator, right? So in refrigerator, heat flows from cold to hot. Okay, but it is possible only when it is forced, right? When air is pumped by compressor. Got it? So I can say that heat cannot flow. Heat cannot flow from cold region to hot region or hot region to cold region without external work being performed on the system. Right? Okay. From hot region to cold region, it will go spontaneously. Got it? It will go spontaneously. But when you talk about cold region to hot region, okay, cold region to hot region, it is not possible without external work. Okay. Now, there's another scientist called Kelvin. I hope all of you know Kelvin, right? Is there anyone who doesn't know Kelvin? Now, this scientist said that the second statement that I said, that no energy can be converted, no amount of energy can be converted totally into work done without exchange of heat. Okay, so he said that no process is possible in which the sole result is absorption of heat and converting into work done. Okay, got it everyone? As simple as that, that's the statement. Means there will be some loss of energy in the process. So when we talk about your engines, like steam engine or Carnot cycle and all those things, okay, wait for some time. Wait, okay, I guess I will be audible. Okay, yeah. So when you talk about steam engine, right? So steam engine is the best example. You can see the steam engine. The steam is converted, or the energy of the steam. The heat energy of the steam is converted into mechanical work done. Got it, everyone? Right? So what do you think? In that case, is it possible to convert whole amount of energy in mechanical work done? Was it possible? No, right? There are many ways in which heat can be lost. And due to that, the efficiency will be less. Got it? So that's what Kelvin said in simple way. Okay? Okay. So we will discuss more about that. So I can say that if we have a source, which is providing some energy E, okay, if we have a source which is providing energy E and it is a cyclic process, okay, then this total energy will not be converted into your useful work done. Some amount of energy will be lost, okay. So I can say that this amount of energy will have some work done, right? It will be used for some amount of work done and some amount of energy will be lost. Okay, got it? Got it, everyone? So that is your statement of second law of thermodynamics, that no cyclic engine. Now this is important in physics. Okay, this is important in physics. For chemistry, you just have to know the statement and this formula, okay, of efficiency, okay, of the engine. Now this will be used in physics mostly. Okay, yes, I am repeating. So the second law of thermodynamics states that no cyclic engine is possible which takes the heat. The source is heat. Okay, right? And this is a cyclic process and convert it total totally into work done. Convert it totally into work done without any change in surrounding or without any loss of energy to the surrounding. Got it, everyone? Tell me. Got it, everyone? Okay. Okay. This is a simple statement. Now there's a work done. If there's a work done, and there is your energy released or energy lost. Okay. Okay. Chulika, you got it or you didn't get it? My question is this. So I'm just saying that it is not possible for all the energy in a cyclic process to be converted into work done. Okay, there must be some amount of energy which will be lost in the process. Okay, that is your second law of thermodynamics. Got it? So this is the formula of efficiency, which is T2 minus T1 by T2. Now, just see this problem. It's a efficiency. You have to calculate the efficiency. This is the sign of efficiency. So efficiency of a heat engine, which is operating between 27 degrees centigrade and 127 degrees centigrade. So convert into Kelvin. So the formula for heat engine, efficiency of heat engine is given by 1 minus T1 by T2, especially Carnot heat engine. Okay. So see, if any heat engine is operating between 27 degrees centigrade to 127 degrees centigrade, its efficiency is only 25%. Okay, this is the formula. You don't have to worry. The formula kahan se aaya? This is the basic formula, small formula. Okay, in physics you will study these formulas in detail. Got it? Right, everyone? Okay, so we will come to our main topic, which is entropy. So I hope all of you watched the videos of entropy. Tell me, how many of you watched the videos of entropy? Everyone watched the video? So after watching the video, you might have a basic idea about what is entropy. Okay, right, everyone? So if I have to explain entropy in one word, so I can just say that entropy is your disorderness. Got it, everyone? Entropy is your disorderness. For example, just take example of classroom. Now when class is going on, the students are sitting in their place, right? They are well arranged. They're not moving here and there. Got it? Or their arrangement is organized, right? Now suppose they get this lunch break. What will happen? Tell me. During lunch break, what will happen? Tell me, everyone. Yes, there'll be chaos. People will be sitting over here and there. They'll be coming out. Yeah, they will be coming out of the classroom, right? They'll be just roaming around here and there. So there'll be chaos, right? So I can say that the disorderness of the class has increased. Yes or no? Tell me. The disorderness of the class has increased. Got it, everyone? Yeah, I know my voice is breaking by because my internet got disconnected. Okay, so I have already told you, just bear with me because I know when my voice is breaking and then it's fine. Okay, so yeah, so I can say that entropy means disorderness. Okay, and now generally, the natural process or any natural process will want to move from lower entropy to higher entropy. Okay, this is your general statement, right? Means the change in entropy for a spontaneous process should always be greater than zero. Got it? Yes or no? For example, just think about again melting of ice, right? Now, when you talk about ice, the first it was in solid state, yes, and then it is converting into liquid state. Okay, got it? Yes or no? Now, what do you think? It is converting from solid to liquid. What is happening to entropy? Even though the temperature is same, see, even though temperature is same, right? Still, the ice is converting into water. So, what will be the change in entropy? Tell me, what will be the change in entropy? Yes. So I can say that when you talk about the molecule of ice, okay, it is well arranged. The movement is restricted because it is in solid state. But when you talk about water, right, the phase changed from solid to liquid, right? There's more movement and the entropy is increased. Got it? Or you can say that there's more disorderness. Yes or no? Tell me, everyone. Yes, very good. So I can say that entropy is disorderness in the process, or disorderness in the system. So entropy is a measure of disorderness. As simple as that. Higher the entropy, greater the disorder. Okay? Any issues? Any issues in that? So technically, whatever the definition would be, indirectly it will mean disorderness only. Okay? Just see first statement. Okay? Now see this. When you talk about the first statement, entropy, it is a measure of the unavailability of system's energy to do work. Okay. Now, this is just the change in language. Okay, this is just change in language. When you talk about the unavailability of system's energy to do work, okay, it means it is the measure of disorder, right? Now, suppose, just think about this. You are low in energy. You don't have enough energy to do work, right? So you will be just sitting over one or two places or just lying down. Got it? Right, everyone? There's a case one. Now case two, you are full of energy. Okay, right? Or just talk about a kid. He is full of energy. So he would be just playing here and there, jumping around. Right, everyone? So you can say that when any system is having enough energy to do work, right? It will be high in entropy. Got it? The disorderness will be more. Got it, everyone? Everyone is getting this? You just have to understand the basics of entropy. What is entropy? Right? Okay. So entropy is disorderness. As simple as that. Entropy is disorderness. Right? So all three statements represent the same thing. Okay? Got it, everyone? Sneha, I just said the same thing, that entropy is measure of disorderness, okay, or unavailability of system, right, or unavailability of system's energy to do work, okay, as simple as that. Okay, okay. So the formula for entropy of a system is this. So ds is entropy of system is equal to change in q reversible for reversible process by t. Now there's lots of confusion between the formulas. Okay, so please remember what I'm saying, right? Because entropy can either be very easy or very difficult. Okay, Shulika, just consider anything around you, anything, right? When you open your pressure cooker, what happens? Vapor escape from your cooker to the atmosphere, right? Got it? So in that case also, yes, steam escapes, right? So in that case also, the disorderness increases. Got it? So that is the case of entropy. When you heat any object, what happens? The molecule will start moving randomly or faster, right? So then also entropy increases. So entropy is just disorderness. Whatever is changing the arranged structure, whatever the changing the order, right? That is your entropy. Got it? Got it, everyone? Okay. So see, properties of entropy change, right? We'll just discuss each property one by one. So the first, just think about this first. When you talk about value of entropy of atoms and molecules, right? We just discussed, right? That entropy of a molecule or atom is basically its arrangement. Yes or no? Right? For example, in case of solid, right? The liquid and gas, I can say that in solid, the entropy is minimum. Okay? Then in liquid, then in gas. Got it? Got it, everyone? Right? Now, when we talk about liquid, so we have two liquids, one at lower temperature, one at higher temperature. So I can say that the liquid at higher temperature will have higher entropy. Got it? As simple as that. Okay? So if you understood what is the basic definition of entropy, these concepts would be easy to understand. Right? Yes, OS? But there are other parameters also. Okay? So see, what about the entropy at absolute zero? Tell me, what about entropy at absolute zero? Yes, very good, OS. Everyone, tell me, what will be the entropy at absolute zero? Think about this. It will be zero, no? Not small, it will be zero. Because what's the definition of absolute zero? It's the temperature at which all the motion ceases to, right? Or all the motion becomes zero. Got it? All the particles cease to move, right? So entropy will be zero. So we have discussed first point, second point, and third point. Got it? Now fourth point. right? So obviously, as I said, that any spontaneous process will move from state of lower entropy to state of higher entropy unless and until equilibrium is achieved. Got it? Got it, everyone? Right? So entropy and disorder also have association with equilibrium. Okay, disorderness or entropy, okay, or change in entropy is possible until unless equilibrium is achieved. Yes or no? Tell me. Yes or no? Got it, everyone? Right? Okay. So at equilibrium, just think about this. At equilibrium, what will be changed in entropy? At equilibrium. Tell me. What do you think? Yes. Okay. Okay, very good. Right? Now see this physical significance of entropy. So I can say that with change in entropy, I can talk about the randomness of a system. If change in entropy is positive, change in entropy in positive, which means the system is moving from less random state to more random state. Yes or no? Tell me. Yes or no? So randomness or disorder is same, right? So I can say that greater the disorder in the system, greater its entropy, right? I hope all of you are getting this concept easily. Now just think about this, right? Changes in the system with different parameters. First is change with constant volume. Suppose volume is constant and temperature is increased. Just imagine, right? Temperature is increased and volume is constant. What will happen? Tell me. The particle will move faster, right? Pressure will be more, right? Randomness will be more, and there will be positive change in entropy. Got it? Right or not? Right, everyone? Okay. So this is your first variation. Now, second, if temperature is constant. Now, if temperature is constant, I'll give you one small example. Just think about this, right? And first case, just talk about first case. We have a small classroom. Everyone is sitting over there, right? Now, just imagine in the classroom, someone saw a snake. Suppose, what will happen? Tell me, what will happen? If someone saw a snake in the classroom, what will happen? So everybody will start running here and there. Got it? Right? So I can say that. So here snake was a reason for the movement of the particle, right? In the same way, when you talk about temperature, so the result of increase in temperature will be increase in kinetic energy, right? Got it? And the particles will start moving. Got it? Okay. Okay. Now just take another example. Suppose instead of classroom, your class is taken in auditorium, and you are same number of students, right? Number of students not changing. Now what do you think? In which case you have more freedom to move? In first case or in second case? Tell me. In a classroom or in auditorium? Obviously auditorium. Got it? So in second case, I can say that if volume is increased, keeping temperature constant, still the entropy will increase. Or delta S is positive. Got it, everyone? Everyone is getting this concept? Tell me, everyone is getting this concept? Okay? Okay, very good. Very good. Now see this. This we have already studied, right? Now see, we know that entropy of liquid, solid, and gas are in this order. Entropy of gas is very high, then liquid, then solid. We have already discussed this. Okay? Now just imagine, suppose I'm having a compound A, which is, wait, compound A is your solid, suppose, solid. It is converting into B plus C, right? But this is gas, this is gas. Now tell me what is delta Ng? Tell me, what is delta Ng? Everyone, what is delta Ng? Delta Ng is the number of change of gaseous molecule. Okay, so this is equal to Ng of product minus Ng of reactant. Okay, right? Now tell me, in product, how many gaseous molecules do we have? Tell me, how many gaseous molecules? 2, na? B and C, right? Both are gases. And in reactant, we have 0. So I can say that delta Ng here is 2, which is greater than 0. Got it, everyone? Got it, everyone? So just think about this. If system is moving from A to B and C, what do you think? Entropy will increase or decrease? Tell me, entropy will increase or decrease? Increase, right? Got it, everyone? Got it? Everyone is getting this concept? Yes or no? Everyone is getting this concept? Okay, very good. Now, if I'm taking this example, N2 gas plus 3H2 gas, then it is giving NH3 gas. Now tell me, if you talk about this process, right? N2 and H2 is forming 2NH3. What will be delta S? Greater than 0, less than 0? Tell me, will it be greater than 0 or less than 0? So first you have to calculate delta N, right? So in this case, delta N is equal to what? 2 minus 4, which is minus 2. So delta N is negative. Or logically you can say that more number of gas molecule is converting into less number of gas molecules, right? So disorderness will be less. Got it? Right? So delta S will also be less than 0. So that's what we have studied over here, right? If delta Ng is greater than 0, then delta S is greater than 0. If delta Ng is less than 0, then delta S is less than 0. Now, if delta Ng is equal to 0, then delta S should also be equal to 0. Got it? This was just example, Karishma, right? This is just an example. Okay. Okay. That N2 plus 3H2 gives 2NH3. So the number of gaseous molecule is decreasing, right? So if number of gaseous molecule is decreasing, then the randomness will also decrease. Got it? Hence, entropy will be less than 0. Okay. Any issues? The next is atomicity and disorderness. Now just think about this. If we have more molecule, if we have a molecule with more number of atoms, then obviously the disorderness will be more, right? Right, everyone? Tell me. Suppose we have 2 classrooms. In one classroom we have 10 students, and in second classroom we have 1 student. Sorry, not 1 student, 5 students, right? Now what do you think? Which classroom will have more disorderness? First one or second one? Tell me. Which classroom will have more disorderness? First one, right? Got it, everyone? Anyone have any issues? Got it? Okay. Okay. Now one should ask, what will happen if atomicity is same? Now, if atomicity is same, then the entropy will be high for a substance having more molecular mass. As simple as that. Okay, got it? So these are just theoretical concepts. You don't have to worry about anything. Okay, got it, everyone? Tell me, got it? Okay, very good. Now just think about this. What will be total change in entropy or entropy of universe, right? So we have system and surrounding. Now just think about this. This is the sum of entropy for system and sum of entropy for surrounding is equal to 0 for reversal process, right? If I'm saying that this will be 0 for reversal process, can you agree with that? Tell me, can you agree with that? Because I said that change in entropy at equilibrium will be 0. Yes or no? Tell me. And in reversible process, it's a very slow process, right? But I can say that in reversible process, each step is in equilibrium. Got it? Right, everyone? That's why the net change in entropy is 0. Now, when we talk about irreversible process, so obviously irreversible process occurs spontaneously, right or not? Tell me. Irreversible process occurs spontaneously, right? So obviously the change in entropy, net sum of change in entropy should be greater than 0. Got it, everyone? Right? Yes or no? So if you add both, right? Or if you want to write a general statement, so I can say that net sum of entropy due to system as well as surrounding will be greater than equal to 0. Got it, everyone? Tell me. Got it? Right? Okay. Okay. Next, again, entropy change for isolated system. It will be same. Okay, don't worry about that. Now we will see the equations. Now it might sound confusing. Don't worry about that. We will just get the same statement, right? Now we have a Clausius inequality. So I'll just tell you what is Clausius inequality. So Clausius inequality says that T delta S, right, is less than Q. Okay. Now, T's delta S is less than Q. Yeah, yeah. Okay. T delta S will be greater than Q. This is the Clausius inequality. You don't have to worry about those things. It's not in syllabus. So if you don't get it, don't worry about that. Okay? Yes. So see, this is your Clausius inequality, right? So Clausius inequality says that for any process to be spontaneous, T ds should be greater than Q. That's it, right? That's it. So you don't have to worry about what is Clausius inequality. It is not there in any syllabus. Okay? Just have to know this statement. Okay? Okay. So we know that if you rearrange that, so I can say that if you have state A and B, if A and B, we have two processes from state A to state B. So the first process is irreversible, and the second is irreversible. So what kind of process is this? Tell me, what kind of process is this? Overall process is, tell me, cyclic, yes or no? Tell me, yes or no? This is a cyclic process, right? Okay. Now we know that according to process inequality, total sum of Q by T in a cyclic process should be less than 0. Right? This is a statement. Okay? This is the statement. The total sum of Q by T, okay, in a cyclic process is less than 0. Right? So this is reversible process and this is irreversible process. And this is the path taken by the reversible process. So I can write like this. Total sum of Q by T for A to B. Now A to B is irreversible. So it will be Q irreversible by T plus from B to A, which is Q reversible by T, should be less than or equal to 0. This is the statement. कहाँ से आया? नहीं सोचना. This is the statement. Got it? Tell me. Got this? Yes or no? Right? Now just take this to this side. As simple as that. Just take this to this side. So we will get this summation of A to B, Q irreversible by T is less than or equal to minus Q reversible by T. Yes or no? Tell me, yes or no? Right? And we know that for reversible process, right? If you go from A to B or from B to A, okay, A to B or B to A, Q by T for reversible will be same, right? The only difference would be sign. If you go from A to B, it will be positive, right? Then B to A will be negative. Got it or not? Tell me. Did you get this? Yes or no? Yes or no? Tell me. Right? So I can say that negative of Q reversible by T, B to A, see B to A, right? Negative of Q by T from B to A should be positive from A to B, right? So this is positive A to B. Got it, everyone? Tell me. Everyone is getting this? Okay? So even if you don't get, don't worry. No issues on that. Okay? Because ultimately you have to just know the statement that we already know. That delta S total is greater than 0. That we have already studied. Right? So see this. So this is statement for reversible process. Right? So I can say that d Q reversible by T is D system AB according to the basic definition of entropy, right? This is according to the basic definition of entropy. Yes or no? Tell me. Yes or no? Right? If I mix this and this, we will get this equation. Now this might seem confusing. Okay, this might seem confusing, right? But don't worry, you just have to focus on this statement. Okay, that for isolated system, net change in entropy is greater than 0. My voice is not breaking, Jitendra. It is fine actually. Okay, because I can hear myself also. So if I can hear myself, it is fine, right? Everyone can hear me. Tell me, is my voice breaking? Because I can hear myself clearly, right? Jitendra, your net is having trouble, right? Skynet. Okay, so in this whole process, you just have to remember this statement that for isolated system, net change in entropy is greater than zero. As simple as that. Okay, that's it, right? So this is the line that you have to remember. This one, only this one. You don't have to worry about these things. Okay. Now we will discuss the basic formula of entropy. Okay, everyone, right? So let's see. Let's see the definition of entropy and derive some formulas, right? Now we know that. Let's see the definition of entropy. So basic definition of entropy was dq, just write entropy. Okay, so dq ds is equal to dq by t. Yes or no? Tell me. Yes or no? Right? We'll go step by step because this is important. Till now we have studied delta S is greater than 0, delta S is greater than equal to 0 for any spontaneous process, right? Delta S total, right? Isolated system is greater than 0. As simple as that. Now, ds is equal to dq by t, and we know that q is equal to u plus w. Yes or no? Tell me yes or no. So ds should be equal to du plus dw by t. Yes or no? Step by step. Just follow me step by step. So this is du by t plus dw by t. Okay? Okay, everyone? Now let's integrate this. So integration of ds from S1 to S2 is equal to, now we know that du is equal to ncv dt by t from 0 to t, suppose, or from t1 to t2. T1 to T2. Yes or no? Tell me. Tell me, everyone. Right? Everyone is getting this. Tell me. Okay. Okay, very good. Now I told you that except first law of thermodynamics, everywhere we'll be using P internal. Or since we will be using formulas at reversible process, you can just take P internal. Okay. Got it? So this W can be as plus P dV by T integration of. Got it? Yes or no? Tell me. Yes or no? Now what is P by T? What is P by T? Tell me. dV is equal to nRT. So P by T is equal to nR by V. Yes or no? Yes, everyone. Very good. nR by V. Very good. Got it? Step by step. Everyone is getting this step by step. So let's see. So I guess everyone is getting till this step. Okay, sorry. Yeah, everyone is getting till this step. Right? So NCV is a constant. So I can just take out NCV after integration or outside the integration. Integration of 1 by t dt from t1 to t2 plus, now p by t is nr by v. So I'll just take nr outside, is 1 by v dv from v1 to v2. Got it, everyone? Right, everyone? So we know that integration of 1 by x dx is equal to ln x, right? In the same way, it will be ln t2 by t1 plus nr ln v2 by v1. Yes or no? Got it, everyone? Tell me, got it? Right? So this is the first formula of delta S. Okay. Now, try converting V1, V2, right? Try converting V1, V2, V1 by V2 in terms of P2 by P1, right? Try doing that. Okay. And then see the formula. Everyone, just try substituting V1 by V2, right? Okay. Now temperature is not constant. First of all, temperature is not constant. So this statement is wrong actually, right? Yeah, so you cannot write this, but you can write this. P1 V1 by P2 V2 is equal to T1 by T2, right? So V2 by V1 can be written as P1 into T2 by P2 into T1. Got it, everyone? Wait, I think it's very small. Let's write it bigger. So all I'm saying is, we know that P1 V1 by P2 V2 is equal to T1 by T2 if number of moles is constant. Then V1 by V2 is equal to P2 by P1 into T1 by T2. As simple as that. So use this and find the value of delta S in terms of pressure. Tell me, everyone. What will change? Tell me what will change. So guys, replace V2 by V1 with pressure. Okay, that's my problem. You have to replace volume with pressure, right? Try, everyone. It's easy actually. There's very small change. See what will be the change. No one has answered till now. So it will be NCV ln T2 by T1 plus this term. be nr bracket ln. Now see, v2 by v1 can be written as p1 by p2 into t2 by t1. Yes or no? Tell me yes or no. Everyone got it? And we know that log a into b is equal to log a plus b. So it is ncv ln t2 by t1 plus nr ln t2 by t1 plus ln p1 by p2. Got it, everyone? Yes or no? Now let's see this. N ln t2 by t1. Let's take this constant. So we will have cv plus r, right, from this first two terms, plus nr ln p1 by p2. Got it, everyone? So what is cv plus r? Tell me. What is cv plus r? Anyone? What is cv plus r? Yes, very good. It is cp. So see this. It is nothing but ncp ln t2 by t1 plus nr ln p1 by p2. Got it, everyone? Tell me, everyone got this? So if you see this, there's only one change, right? cp is replaced by, sorry, cv is replaced by cp, and v1 by v2 or v2 by v1 is replaced by v1 by v2. That is understood, right? Because it is irreversible, sorry, inversely proportional. Got it? So we have these two formulas. Anyone have any issue in this? Tell me, anyone have any issue with this? Right? Everyone is getting this formula? So this is just formula putting getting. So you just have to use these two formulas, nothing else. Okay? So note it down. Note these two formulas down. Okay, so I guess all of you have written this. So let's see. Now when you talk about different processes, so we know that the basic formula was this: delta S is equal to NCV ln T2 by T1 plus NR V2 by V1, or NCP ln T2 by T1 plus NR ln P1 by P2. Got it, everyone? Yes, got it? Yes, very good. Now, if you talk about isothermal process, just think about this. Isothermal process, which means this is 0 or this is actually 1. So this whole term is 0. Yes or no? Isothermal process. In isothermal process, I can say that this term and this term will be 0, right? So delta S system is just the second term. Got it? Right? And we already know that delta S of surrounding is equal to minus delta S of system for reversible process, and delta S of surrounding is equal to basic definition Q reversibility for irreversible process. Got it? right? Why? Because here we substitute u plus w because it was for system. Got it? समझ में आ रहा है? Okay? Okay. For isobaric process, baric means this will be 0, right? Okay. See, isobaric process, you will have just first term. Got it, everyone? Tell me. Got it, everyone? Right? Same thing for reversible and irreversible. Okay. For surrounding, it is minus delta system. For surrounding, for irreversible, it is q reverse q surrounding by t. Okay. Now isochoric process again same. First term. The only difference is here it will be NCP and here it will be NCV. So you have to note this. Okay. Now, adiabatic process. Tell me, what do you think? Will there be any change in adiabatic process? Tell me. Or the formula will be same? Or there will be something? What will be delta system for the adiabatic process? Tell me, everyone. What will be delta system for adiabatic process? Anyone? Yes, Aviram, very good. Same means what? NCP ln T2 by T1 plus NR ln V2 by V1 or something else? Tell me. See, you have to know what's the basic definition of adiabatic. Tell me, what is the basic definition of adiabatic? The basic definition of adiabatic is what? Q0. Yes or no? Q0. So if Q is 0, then delta S system should be 0. Yes or no? Right? Got it? So for reversible process, right? Delta S system should be 0. Okay, that is the concept for reversible process of system. Now for irreversible process, it will be same as formula. Okay, got it, everyone? For irreversible process, it will be same as formula, but for reversible process, it will be 0. Okay, got it? Okay, let's try to solve one problem based on that. So we have a problem. Try solving this problem. Okay, this will be the last problem of today's class. Right? Try solving this problem. Everyone try solving this problem. If you want log value, please ask me. Everyone, tell me the answer. Okay, have you solved? Right? Okay, Aviram has solved. See everyone, let's see the formula, right? Now, first thing that you have to do, write the formula. Now here we have what? 1 atm, 1 atm, 2 atm. State A to B, pressure is constant, but volume is changing. Just see this. State A to B, pressure is constant. Got it? So it is easier to use which formula? Tell me. It is easier to use which formula? P wala or P wala or B wala? Yes, NCP wala. Very good. So from state A to B, from state A to B, okay? See this. We can use NCP ln T2 by T1 plus NR ln P1 by P2, because this will become 0. This will become 0, right? This will become 0. Got it? Because pressure is equal. Got it, everyone? Tell me, everyone got this? Yes or no? So that is your answer, as simple as that. You don't have to write. Now you can solve this also, because CP, monoatomic, we have given, which is 3 by 2 R, and this is ln 3. Now in order to convert ln into log, you have to multiply by 2.303. Please note this. Okay, so it will be 2.303. Then you can find the value of log. So log 3 is, tell me, 0. What is log 3? 477 minus 0. Log 2 is 3, right? Got it? So you can solve this. In the same way, from state B to D, right? Volume is constant. Volume is constant, 3.6, and this is also 33.6. Okay, got it, everyone? Right? Everyone got this problem? Tell me, everyone got this problem? Yes or no? Okay, okay, very good. Thank you, everyone. So we will continue the same topic in next class, which is tomorrow. We'll try to complete this topic tomorrow. Okay, I hope all of you understood these things, right? Just go through your NCERT, okay? And please watch videos after the class and make your own notes, okay? Okay, bye everyone. Thank you, everyone. Okay, bye everyone. Okay, bye everyone.